Have you ever looked at one of those physics problems with a bunch of blocks all pushed together and just felt your brain freeze? Yeah, they can look really complicated. But guess what? There's actually a super straightforward way to tackle them. Today, we're going to break down a classic example, step by step, and give you a clear toolkit to solve any problem just like it. Let's get into it.
So, here's the setup. We've got 3 blocks, 1 kilogram, 4 kilograms, and 2 kilograms. From the left, there's a 50 Newton force pushing the whole thing, and from the right, a 12 Newton force is pulling back. So the real questions we need to answer are, how fast is this whole train of blocks accelerating? And what about those forces happening between the blocks, the ones we can't see?
Okay, so the first thing we got to do, and this is super important, is to fight that urge to look at each block by itself. Instead, we're going to start by zooming way out and treating all 3 blocks as if they're one single solid object. This is the absolute key to finding the overall motion. In physics, we've got a name for this. We call it a system. And when we define our system like this, it lets us do something really powerful. We get to ignore the forces happening inside the system for a minute. You know, the little nudges the blocks are giving each other, those are internal forces. For now, all we care about are the big external forces acting on the group as a whole. So, how do we do it? It's basically a 3-step game plan. First, we'll add up all the external pushes and pulls. Second, we'll find the total mass of our system. And third, we get to use the one and only, the most famous equation in all of physics, Newton's second law. F equals ma. All right, let's put this into action. The external forces are pretty clear. 50 newtons pushing to the right and 12 newtons pulling to the left. Since they're fighting each other, we just subtract them. That gives us a net, or an overall external force of 38 newtons pushing the whole system to the right. Step 2, even easier. We just add up the masses. 1 plus 4 plus 2, boom! A total system mass of 7 kilograms. See? Now we have our net force and our total mass. We're ready to find that acceleration. And this is where the magic of the system approach really shines. We take our net force, 38 newtons, and we divide it by our total mass, 7 kilograms, and we get an acceleration of about 5.43 meters per second squared. And just like that, we've cracked the first part of the problem. Okay, we know how fast the entire system is speeding up. Now we can change our perspective. It's time to zoom in and play detective to find those hidden forces acting between the blocks. So you can really see the 2 different hats we're wearing here, right? The zoomed-out system view was perfect for getting the big picture, the overall acceleration. But to find those internal forces, we have to zoom in and apply that same acceleration to just one block at a time. The problem asks about the force between the 1 kilogram and 4 kilogram blocks. So what do? Simple. We mentally draw a box around just that first 1 kilogram block and analyze only the forces acting directly on it. So if you're this little 1 kilogram block, you've got that big 50 Newton force pushing you from behind. But wait, you're also bumping into the 4 kilogram block, and it's pushing back on you. We'll call that pushback the normal force, or just N. So the total net force on this one block is 50 minus N. Now we just bring back our old friend, Newton's second law, but we apply it only to this single block. The net force, which we just said is 50 minus N, must equal this block's mass, just 1 kilogram, times the acceleration we already found for the whole system, 5.43 meters per second squared. Now, we could solve for the exact number, but check this out. We don't even have to. The question is answered right here in this equation. It shows us, plain as day, that the normal force, N, is definitely not 50 newtons. It's got to be something smaller, because its value depends on how fast everything is accelerating. You know, this actually leads us perfectly into the final part of our puzzle. What's the net force on just one block? Let's say that 2 kilogram block at the very end of the line. And the answer, honestly, is so simple and elegant. The definition of net force is right there in Newton's second law. It's a golden rule of physics. The net force on any object is always, and I mean always, just its mass times its acceleration. That's it. Let's just see that in action. For our 2 kilogram block, we take its mass, 2 kilos, and multiply it by the system's acceleration, 5.43 meters per second squared. And that gives us a net force of 10.86 newtons acting specifically on that block. And that's our answer. The net force on any single block in this chain is simply its own mass multiplied by the shared acceleration of the whole system. It's a fundamental principle that ties everything together. So we've completely taken apart this problem. We've solved all three parts. Now let's put it all back together into a simple toolkit that you can use on pretty much any connected block problem you ever come across.
Here it is, your 4-step method for success. Step 1. Zoom out. Treat everything as one big object. Step 2. Find that acceleration. Use the total mass and only the external forces. Step 3. Zoom back in. Pick one block to focus on. And step 4, find the internal forces. Apply F equals ma to that one isolated block and solve for whatever you need.
So there you have it. You've totally got the fundamental approach to solve these kinds of problems now. But here's a little something to chew on. We did all of this assuming the surface was perfectly smooth, right? No friction. How would our entire calculation, especially that first zoom out step, change if we added friction into the mix? That's a great question to think about for next time.